So capacitive transducers, they are those transducers which are used for the measurement of different physical quantities like displacement, pressure, flow, level, torque, and these physical quantities are measured with the help of change in the capacitance. Now, if we define the capacitance of a parallel plate capacitor, it is given by the relationship C equals to epsilon A by D, where C is the capacitance of the capacitor, epsilon is the permittivity of the medium, A is the overlapping area of the plates, and D is the distance between the plates. So from this equation you can see that the capacitance, it is directly proportional to the permittivity and the overlapping area of the plates and inversely proportional to the distance between the plates. So when we are changing any of these three parameters, we are changing the capacitance. So either changing the permittivity of the medium, or the A, that is overlapping area between the plates, and D, the distance between the plates. So by changing any of these three parameters, we can change the capacitance. And by measuring the change in the capacitance, we can measure the physical quantities like displacement, pressure, flow, etc. So capacitive transducer, they are based on the principle that they are measuring the physical quantities by measuring the change in capacitance, which is due to the change in any of these three parameters. So here we are going to study about the capacitive transducers, which are using the change in capacitance using the variation in the dielectric constant. This dielectric constant, it depends upon the dielectric medium which is used between the plates. When we are using a capacitor, so the capacitor consists of two plates, and in between those two plates we are having a dielectric medium. That dielectric medium will have a dielectric constant, and this dielectric constant, if we are varying it, we are varying the permittivity of the medium. So here we are going to study about the capacitive transducer, which are used for the measurement of different parameters by changing the dielectric constant. Let us first see the diagram for the circuit which is used for the measurement of displacement by measuring the change in the capacitance. So this is an arrangement which is used for the measurement of the displacement by measuring the variation in the dielectric constant. Here you can see we are having two plates, top plate and the bottom plate. In between these two plates we are having a dielectric medium which is shown by the dotted points. Okay, now when these top and the bottom plates, you can see that it is having two mediums in between it. This medium is having the dielectric between it, and this portion is having the free space between it. Now this dielectric medium, it is going to have the value of the dielectric constant, that is the permittivity value will be there. So for this much portion we are going to consider the dielectric medium, and for this much portion we are going to consider the free space. So if we write the capacitance value, so for this much portion where we are having the dielectric, which is having the value, that is the permittivity of the medium, is given by epsilon naught epsilon r, where epsilon naught, it is the permittivity of the free space, and epsilon r is the relative permittivity. So the relative or the permittivity of this medium, of this dielectric medium, is given by epsilon naught epsilon r. Okay, so here we have written epsilon naught epsilon r omega L2 is the length of the plates, or we can say the distance, the area. Okay, because area is what? Length into the width. So length here is L2 and width is W. So for this much portion we are having the capacitance value as this. Now in this remaining portion the length is L1, the width is W, and because here the free space is available, so we are going to use the permittivity as epsilon naught. So for this portion we are having epsilon naught omega L1 by D, and for this portion we are having omega epsilon naught epsilon r omega L2 by D. So that is the total value of the capacitance. Now from here C will be equals to epsilon naught omega by D, and inside we are left with L2 plus L1 plus epsilon r L2. Okay, if we take common from here, so omega naught W and D will be common, we are left with L1 plus L2 epsilon r L2 we are left with. Now suppose that a displacement is being given to this capacitor arrangement. Okay, now let us suppose that this dielectric, it is being moved through a distance x. Now due to the movement of the dielectric, the capacitance is going to change, and this change in capacitance is suppose del C. So this can be an increase in the capacitance or it can be decreased. So we can have positive or negative value here. So C is changed to C plus del C. Now let us see that what will be the value of this new capacitance. Now as the dielectric medium is moved, the length or the length overlapping area is going to change. Okay, and overlapping area is going to change, the length is going to change here. So it is moving in the direction L1 minus x, means we are moving this plate over the dielectric medium. In this direction we are moving. So L1 is decreasing and L2 is increasing by the amount x. So we are new distances will be L1 minus x and L2 plus x. So according to that, here it will be changed. It will become L1 minus x and it will become L2 plus x. So we have taken epsilon naught omega by d common. Here L1 minus x plus epsilon r L2 plus x, they are remaining. Again simplifying this. So when we simplify it, epsilon naught omega by d L1 plus epsilon r L2, they are left, and on the other side we are left with epsilon naught omega x by d we have taken common. So epsilon r minus 1 are remaining. So C plus del C will be, this value we have already obtained. Earlier we have obtained epsilon naught omega L1 by d, that is this point, plus epsilon naught omega epsilon naught epsilon r omega L2 by d, that is this value. So this is the initial capacitance of the transducer. So we can replace this whole term by C, plus we are having epsilon naught omega x upon d epsilon r minus 1. So the change in capacitance is del C equals to this term, that is epsilon naught omega x upon d epsilon r minus 1. So from this equation you can see that the change in the capacitance is directly proportional to the displacement x. So when we are doing any variations in the dielectric constant, we have seen that the displacement and the change in the capacitance, they are proportional to each other, they are linearly related. Okay, so in this way the displacement can be measured by changing the capacitance due to the variations in the dielectric constant. So this is one way in which we can use the capacitive transducers based on the principle of variation of dielectric constant for measurement of displacement. Now let us see another capacitive transducer which is using the same principle, variation of dielectric constant, for the measurement of the liquid level. Let us see the arrangement for this. So this is the arrangement which is used for the measurement of the liquid level. Now here variations are done in the dielectric constant. We can see that we are having a tank. In that tank liquid is filled. We are having the cylindrical electrodes here. This is acting as the plates and this is acting as the dielectric medium. Liquid is acting as the dielectric medium here. So we are having different heights here. For this much height we are having the vapors as the dielectric medium, and for this much height we are having the liquid as the dielectric medium. So as the level of this liquid is changing, the amount of dielectric present is also changing. According to that, the capacitance will change. So as the capacitance is changing, we can measure the change in capacitance to measure the change in the liquid level. Okay, because between the two plates of the capacitor, the dielectric medium is the liquid. So as the level of the liquid is changing, the capacitance, or we can say the dielectric constant, is changing, and so the capacitance is changing. Let's see how we can measure the capacitance and the liquid level. So in this arrangement, electrodes are used, which are the two concentric cylinders. The non-conducting liquid, it is acting as the dielectric. Remember here, the liquid should not be a conducting liquid. Okay. Also at the lower end of the outer cylinder, there are holes so that the liquid can pass into the dielectric or in between the two cylinders. Okay. So that as the level is increasing, we can say the capacitance is changing. Okay. Now here the value of capacitor is given by, so the value of capacitance is given by 2 pi epsilon naught epsilon 1 h1 plus epsilon 2 h2 upon log to the base e r2 by r1, where epsilon naught, it is the permittivity of the free space, epsilon 1 is the permittivity of the liquid, epsilon 2 is the permittivity of the vapors, because here you can see that vapors are acting as the dielectric medium, here liquid is acting as the dielectric medium. So these are the dielectric constants for these mediums. So epsilon 1 is present for height h1, the liquid height, and h2 is the height, remaining height, h minus h1 we can say. R2 is the radius of the outer cylinder, and r1 is the radius of the outer radius of the inner cylinder. Okay, let's define these variables here. H1 is the height of liquid, H2 is the height of cylinder above the liquid, or we can say the remaining height. Epsilon 1 is the relative permittivity of liquid, epsilon 2 is the relative permittivity of vapor above liquid. R2 inner radius of outer cylinder, and R1 outer radius of inner cylinder. Epsilon naught permittivity of free space. So these are the various variables in this formula. Now this equation, it is based on the assumption that H is very greater than R2 and R2 is very greater than R2 minus R1 or very greater than A. Means the radius of the cylinder, the inside radius of the outer cylinder is very greater than the difference between the two radius, and the total height of the cylinder is very much greater than the radius. Okay, so in that case R2 is equals to R plus A, or we can say R1 is equals to R. So in that case capacitance is reduced to 2 pi epsilon naught. So in this way we can say that the liquid level is changing, as the level of the liquid is changing, the dielectric constant value is changing, and due to that the change in the capacitance is occurring. So in this way we can measure the liquid level by measuring the change in the capacitance. So in this video we studied about the various types of capacitive transducer which are using the principle of change in the capacitance using variation in the dielectric constant. We saw here that these capacitors can be used for the measurement of not only the displacement but also for the measurement of level of the liquid, and so for the pressure, force and other physical variables. So I hope that this topic is now clear to you. Thank you.